Our first stop takes us to Mercury, the smallest and innermost planet in our solar system. Despite its proximity to the Sun, Mercury has no atmosphere to retain heat, leading to drastic temperature fluctuations. Don't let its size fool you, though. This tiny planet is packed with mysteries. This rocky world is a fascinating place, with a surface marked by craters and cliffs, some of which are taller than Mount Everest. Reaching Mercury isn't a walk in the park, given its close orbit to the Sun, but it's not the most daunting journey either. The challenge lies in slowing down enough to be captured by Mercury's gravity. NASA's Messenger spacecraft, launched in 2004, took a rather roundabout route to get there, making multiple flybys of Earth, Venus, and Mercury itself, utilizing planetary flybys for gravity assists. These maneuvers are crucial for adjusting the spacecraft's speed and trajectory. This clever maneuver helped conserve fuel, allowing the spacecraft to travel further with less propellant, but extended the journey to about 6.5 years. Imagine that, years just to reach the closest planet to our Sun. Mercury's proximity to the Sun makes it a challenging target, but also a rewarding one for scientists. Of course, with advancements in propulsion technology, future missions could potentially shorten this travel time significantly. Faster propulsion systems and more efficient spacecraft designs are on the horizon. Who knows? Maybe one day we'll be zipping to Mercury for weekend getaways. The future of space travel holds endless possibilities. Next on our itinerary is Venus, often called Earth's sister planet due to its similar size and composition. However, don't let that fool you. Venus boasts a thick, toxic atmosphere and a surface hot enough to melt lead. Despite its inhospitable nature, Venus has been a prime target for exploration. NASA's Magellan spacecraft, launched in 1989, spent 4 years orbiting Venus, mapping its surface with radar. The journey itself, however, was considerably shorter than Messenger's trek to Mercury, taking just over a year to reach our superheated neighbor. This difference in travel time highlights the importance of orbital mechanics and how we can leverage the motion of planets to our advantage. It's like catching a cosmic wave. Well, we don't need a spacecraft to reach this one, do we? Earth, our pale blue dot, is where we call home. It's the only known planet so far to harbor life as we know it. But let's not linger too long on familiar ground. We've got a whole solar system to explore. So, let's use this moment to appreciate the preciousness of our home planet and the incredible journey we're about to continue. Next stop, the red planet, Mars, humanity's next frontier. The allure of this distant world has always been strong, drawing the curious and the adventurous alike. This dusty red world has captivated our imaginations for centuries, inspiring countless stories, theories, and dreams of exploration. And now, we're closer than ever to setting foot on its surface. The dream of walking on Mars is no longer confined to the realm of science fiction. But just how long does it take to reach our celestial neighbor? Well, it depends. The journey to Mars is a complex dance of celestial mechanics. The Curiosity rover, our intrepid robotic explorer, took about 8 months to complete its journey back in 2012. This mission marked a significant milestone in our quest to understand Mars. However, the travel time to Mars can vary depending on the positions of Earth and Mars in their respective orbits. The distance between the two planets changes as they move around the Sun. Sometimes it's like catching a train. You have to wait for the optimal alignment. This alignment, known as the Hohmann transfer window, occurs approximately every 26 months. With upcoming missions aiming for crewed landings, the stakes are higher than ever. The challenges are immense, but so are the rewards. Scientists and engineers are hard at work developing technologies to shorten travel times, improve safety, and ensure the success of these missions. Their efforts are paving the way for a future where Mars is not just a distant dream, but a tangible destination. The red planet beckons, and humanity is ready to answer the call. Hold on tight as we venture further into the solar system, heading towards Jupiter, the largest planet in our cosmic neighborhood. This gas giant is a behemoth, with a swirling atmosphere of colorful clouds and a powerful magnetic field. Reaching Jupiter is no small feat. NASA's Juno spacecraft, launched in 2011, took almost 5 years to reach this gas giant. Juno's mission is to study Jupiter's atmosphere, magnetic field, and internal structure, providing us with valuable insights into the formation and evolution of gas giants. Imagine the data we're receiving from a spacecraft that's been traveling for years. It's a testament to human ingenuity and our thirst for knowledge. Prepare to be dazzled as we approach Saturn, the jewel of our solar system. Its iconic rings, composed of countless icy particles, are a sight to behold. Reaching this ringed wonder requires a significant commitment in terms of time. The Cassini spacecraft, a marvel of engineering, embarked on its 7-year journey in 1997. Cassini spent over a decade orbiting Saturn, sending back breathtaking images and revolutionizing our understanding of this gas giant and its moons. 7 years might seem like an eternity, but the discoveries made by Cassini were well worth the wait. Our journey takes us now to the outer reaches of the solar system, where we encounter Uranus, an ice giant with a frigid atmosphere and a faint system of rings. Reaching Uranus is a truly long-haul mission. Voyager 2, launched in 1977, made a flyby of Uranus in 1986 after a journey of nearly 9 years. Voyager 2's encounter with Uranus provided us with our first close-up glimpses of this distant world, revealing its unusual tilted axis and surprising magnetic field. It's amazing to think that a spacecraft launched when I was just a kid could travel for almost a decade and still send back valuable data. Finally, we arrive at Neptune, the farthest planet from the Sun. This icy giant is a realm of extreme cold and powerful storms. Voyager 2, our trusty interstellar messenger, holds the record for the fastest journey to Neptune, reaching it in 1989 after a 12-year voyage. Voyager 2's flyby of Neptune provided us with our first detailed look at this distant world, revealing its great dark spot, a massive storm system, and its intriguing moon, Triton. It's incredible to think that a spacecraft launched during the disco era is still out there, pushing the boundaries of exploration. Watch this video to see if we should colonize Venus instead of Mars.